Assalamualaikum. A very good morning, everyone. My name is Siti SALWA alias from University Technology Malaysia. Today, I would like to present my project entitled Evaluation of an Adaptive Science Curriculum for E-Waste Management through Nature of Science and Project-Based Learning. So this project embodies the core mission of ALIAS-ITeLiC'26, pushing amazing innovation into the future classroom by teaching beyond traditional boundaries. So this innovation is a proud multidisciplinary effort. I want to acknowledge my dedicated team across FAST and CEE-UTM. All right. So e-waste consists of discarded and broken electrical devices. Unmanaged recycling release heavy metals, causing serious socio-scientific debates regarding human health and pollution. However, our formal KSSM science curriculum overlook these social science issues and rarely enforce the nature of science, known as NOS, to trigger epistemic insight in learners. This is our goal, to enforce this approach. Right. So, to solve this educational gap, we developed a highly adaptive learning module, especially for e-waste management. We use the project-based learning to transform how students interact with environmental science. So our research is guided by key objectives. First, to receive the current e-waste interpretation profiles of learners before they engage with modules. Second, to evaluate their action as they obtain knowledge through active project-based learning activities. Third, to identify significant difference in how learners interpret e-waste after going through this module. And fourth, to identify the structural components of NOS using the reconceptualized family resemblance approach, FRA, using it as an indicator to trigger their ideas. Basically, this project was sponsored by several grants, particularly from UNESCO, from our collaborators in Indonesia, and also from Majlis Bandaraya Iskandar Puteri. Next, the originality of this project lies in moving away from static memorization by synthesizing environmental science with dynamic epistemic framework. We transition the student from passive listener to active environmental problem solvers. The added value in curriculum that equips students with cognitive tools to understand the social and scientific facets of e-waste. This aligns perfectly with the vision of ALIAS-ITeLiC'26 by creating a future-ready, adaptable classroom that addresses real-world issues, particularly e-waste, in our project. All right. So now let us examine our result, starting with our methodology for measuring usefulness. So what we can see from this particular slide, we use epistemic network analysis, ENA, to map variation across the nature of science components. Okay, there are 11 elements here. And rather than simple testing, ENA visually maps how a student brain connects scientific concept. So this aligns with ALIAS-ITeLiC'26 because true innovation requires us to measure cognitive growth beyond traditional boundaries. Looking at the usefulness of the EWIS learning module. So this table in the slide shows the cumulative frequency of 11 FRA components across these modules. And the higher frequencies prove our module consistently triggers deep thinking. So it shows that the amazing innovation champion at ITeLiC 26 is measurable. We are successfully tuning theory into student engagement, which is active learning using this module. All right. So moving to this slide, okay, let's visualize the cognitive growth. So the E&A graph for section 1 and section 2 shows the students' conceptual networks beginning to form. As the students start the project, their ideas connect and growth then serve. Okay. So this emphasizes the future classroom, and here we see exactly what future learning look like, a dynamic, growing network of ideas rather than isolated facts. Advancing to the final stage, by section 3, the epistemic network analysis reveals highly complex interconnect cognitive maps. This proof that by end of this module, the student don't just know about the e-waste. They understand its complex socio-scientific impacts. This is teaching beyond the boundaries at its finest. Okay, we can see from all these photos, all right? So this is the some of the photos taken during the project-based learning, okay? So beyond usefulness, our result also heavily emphasize practicality, and innovative curriculum is only valuable if it can be realistically executed by educators and easily adopted by the student. So in this slide, what we can see from this table is actually our evaluation of the modules practically shows highly positive learners reception. The data confirms this module is user-friendly for both teachers and also the students. To realize the vision of ITeLiC 26, and innovation must be practical enough to thrive in the real-world classroom environment, which we have proven here. As we can see, based on the percentage of the improvement up to 92.9%. Okay, continuing with practically. Further practicality metric shows that student maintains high engagement throughout the hands-on project. Student didn't lose interest. They stayed motivated to solve e-waste problem. This sustained action is the hallmark of the amazing innovation we want in our future classroom. So our academic success translates directly into market readiness. As we can see in this slide, we already copyrighted 3 modules, 2 books, and also several general articles published online. Okay, so I would like to represent, this is both of our module. Particularly in this project, we are focusing on using this module called as Odyssey Malar Hijau. Actually, this module has three parts. The first part, okay, the student will go through a short stories on how we can recycle, reuse our e-waste. So there are several activities here, which are 13, okay, specifically 13 activities in this book. For example, these activities, okay. So what they need to do in these activities, so they all the student was introduced how to manage the e-waste, what is the best action that we can take to secure the environment, okay, instead of pollute it with the e-waste. Okay, meanwhile, in the second part of this module, the student will understand more on the e-waste and also specifically knows how to send their e-waste at several local area in their community place. Meanwhile, finally, in the third part, okay, so this is a proven of the activity project-based learning output based on the previous batch in 2024, right? So based on the output from this project, so we try to connect the NOS and prove that the cognitive part is very important to ensure both the teachers and the learners emphasize this NOS approach in their class. Okay, so moving to the next slide. So this project was awarded 5-star rating community program, as we can see from this slide. And this infographic, okay, shows that finally the ultimate validation of our result. In conclusion, we have proven that an adaptive curriculum can elevate students thinking on complex issue like e-waste, for example. So we are building a generation of eco-conscious problem solvers. So thank you to all the judges of ITeLiC 26 for your time. Thank you.